Okay, there we go. So yeah, the title might be a bit deceptive. It's Discipline for AI Innovations, but it's mostly about MLOps. I know like different teams have like different ways of approaching MLOps, so this is just one way of tackling and adding Azure DevOps for machine learning workflows. So a little bit about myself. I'm a data scientist and solution architect for Microsoft Canada. I'm based out of Vancouver, and I am part of the national AI team. So I technically cover like all of Canada, but I generally try to focus on most of our Western customers. So that's from all the way from Victoria all the way to Winnipeg. So I usually work closely with accounts in that region. And I'm also part of the AI Ambassador program for Canada. So I'm usually involved in like hosting hackathons, usually lots of events at UBC because that's very close to where I live. But I do sometimes present at other universities as well. And I know last year I was at the Calgary Tech Summit. So I do sometimes present at Calgary and other cities as well. So on to our presentation. So with Microsoft AI, like what we're doing is really it's about like empowering developers to help them innovate, right? Because that's where all the foundation of AI works begins. Like you need developers to build AI or work with data scientists to implement some sort of like AI solution. And really like our ecosystem targets developers in such a way that they can leverage open source tools, especially with the acquisition of GitHub. We're moving more toward like open source workflows and support like most open source libraries like TensorFlow, sklearn, and so on. And really the end goal is to help organizations digitally transform, and use AI as a tool to drive insights from some of the data that they may have, or use some sort of AI model to generate predictions and improve business and quality of life within business users. And we also help empower people by supporting various, I guess, like environmental awareness programs, AI for good, using computer vision for tracking and monitoring species, endangered species, and other applications. And one other application of using pre-built AI is what we had a couple of years ago, 2 years back, we released the Seeing AI. And this is basically an app that helps individuals that are visually impaired basically use their phone, iOS, Android, and detect objects, have it like call out like the menus, read out the menus using OCR, and so on. So those are just a few examples of the philosophy behind like what Microsoft Research is doing and what their goals are. And a bit more about I guess like the breakthroughs within Azure AI. Essentially, like we were the first to reach parity, human parity across different, I guess, categories such as object detection, machine translation, speech recognition, and even conversational Q&A on different metrics like the Stanford COQA test, the switchboard test, which is like speech to text. And human parity really means that the AI model is performing on par with what the average human would be capable of. So for example, if we look at the ResNet, 96% on the ResNet vision test, that means the average person might be just as accurate at detecting certain objects. And we have a wide range of research teams. As you can see in this map here, we have the core Redmond team down south, or for me down south, southwest for you guys. And then there's a few other locations as well, Microsoft Research, New York, Montreal, New England, India, Beijing, Shanghai, and so on. So it's really a collaboration across like different continents and like different research teams. And as a high-level overview of Microsoft AI, if we were to look at all the different services that we have, I would categorize them into three main categories, such as the knowledge mining category, which is primarily through Azure Cognitive Search. And then there's the apps and AI agents, which is the cognitive services and bots. These are really like pre-built AI services that you can just plug and play and consume. And finally, the core part of the presentation is going to focus on like the machine learning aspect, because it is MLOps, and you can't really do MLOps with just pre-built AI just yet. Maybe in the future we will be, but right now it's going to be like infrastructure as code, and you do need some level of coding to implement like an MLOps pipeline. So more about cognitive services. These are essentially pre-trained models. There's different categories. There's the vision category, there's speech, language, and search. So you can do some sort of like object recognition. You can do custom computer vision model training to detect certain objects. There's speech to text, text to speech, face recognition, emotion recognition, localizing objects within using computer vision. So if you want to detect multiple people or like draw out the regions within a picture that you want to detect, that's all possible with the custom vision service. And in general, it's really all about democratizing AI, where anyone can sort of leverage these tools at all different skill levels and just make a simple API call, submit some data, and get back a JSON response with all the predictions and scores and so on. And then we also have the bot service. So there's different flavors for the bot service. There is the core .NET version with C#, and now we've also added Node.js and Python support. So you can use different like wrappers to build your chatbots and deploy them across different channels. There's also Q&A Maker that builds on top of Azure Search and just allows you to just, I guess, pass on a simple URL that contains some sort of like Q&A questions or like frequently asked questions, FAQs from a website, and automatically detects and extracts those questions and builds a Q&A bot all by itself without even writing a single line of code. And you can take some of these bots and really like deploy them across different channels to your website, to Cortana, to email, to I guess this is Slack, wherever you want, Facebook Messenger, or any other platform to have even greater outreach. So you can perform like a survey if you're like in a residential area and you want to perform a survey to like local residents in like a townhouse setting. If they're in a Facebook group, you can deploy that bot and the manager can ask questions and like get insights, and you can power up a dashboard and generate reports all automatically with some of these pre-built services. So that's more about like the other two pillars, the first two, knowledge mining and the pre-built. So the first, I guess, like the row here talks about the things that I mentioned earlier, like pre-built services. And within machine learning, there's also support for all this, like the tools that you're most comfortable working with, such as VS Studio Code, notebooks, Jupyter Notebooks, command line. So really the whole idea is to allow developers to use like data science tools without having to depend on an operating system or a particular framework. So what we have is the core machine learning service. It's based on the Python SDK, which we also support R now. Like in the recent months, R is also supported, and you can use this SDK. Think of it like a library. Like if you're downloading like a Pandas library for Python, same thing. Like you just download that library, pip install the library, and it installs all the dependencies for you to communicate with the Azure cloud, track your metrics, build end-to-end machine learning solutions from like data ingestion to deploying to Azure container instance or to like an AKS type setting. So it allows you to do all that on without being, I guess, like being tool agnostic. So you can run it on any operating system or like IDE of your choice. And with the open source movement, we support almost all the open source libraries within our framework, and new ones are being integrated, like MLflow, whatever ones that are currently like most popular within the machine learning community, like that's definitely going to be supported. And of course, we have the Onyx, which is like a convert from like one framework. For example, if you're building a model in sklearn and you want to transform it to another format, you can use that as the medium to drive the transformation. And you can use Onyx to power up edge devices. Like, we have the Microsoft Vision AI Kit, where you can deploy models like deep learning models, computer vision models on the edge and have it only score on that local, that camera itself. It runs on Linux, and you can score models and use IoT hubs to push the models into this device, this camera device, and then extract, I guess, predictions through the IoT hub as well, through a bidirectional communication. So within ML, there's so many different applications, and like you can integrate almost any open source tool out there and really make it your own with using like machine learning service and a few other tools that I'll talk about, including like Azure DevOps as well. And in terms of infrastructure, there's also like this. The reason why we put this up here is because when it comes to like machine learning training, CPU does matter. Like the CPU itself depends on like I guess if you're using like a Spark-based framework running like say random forest model, then you may have to use a cluster of CPUs, maybe using Databricks because that's the orchestration environment to run Spark or like PySpark, Scala code. And if you want to train like a deep learning model, then maybe its GPU might be a good choice because GPU has a lot more threads compared to CPU. I made like the new NVIDIA like Titan GPUs may have as many as like 2 or 3 or 4,000 threads for like the distributed computing capabilities and for training deep learning models, because most of these depend on matrix multiplication. So GPUs might be a good choice. So depending on the use case, you may have to use a combination of CPU for like say data transformation, data loading, ELT processes, and then do the training on a GPU. And with Azure Machine Learning Service, it kind of enables you to switch compute as needed for your workflows. And of course, there's the FPGA as well, field programmable gate arrays, which can be used for hardware accelerated inferencing. Some of these FPGAs can be deployed on the edge, and you can have like a by millisecond inferencing on like say let's say a use case where you're detecting people wearing masks or like detecting like distance between people, and you want like high frequency predictions in a crowd, like say you're in a public setting and there's people walking by and you want to enforce that. You can definitely do that. And also you can program these vision AI kits in such a way that none of the faces of people leaves that hardware, only the predictions leave the hardware and go to some sort of like reporting, like an aggregated reporting system. So just one example of like use case during the pandemic. I'm just gonna take a quick break there and see, go back and see if there are questions because I'm not able to see the screen.
I don't see any questions in the windows yet, and nobody's hands up, so.
Gotcha. Okay, so I'll go back to the presentation.
So just a reminder to people while you're getting set back up, if you do have a question, raise your hand and we'll make sure that we get you queued up.
Awesome. Okay, so back to our, like, I guess our main focus is going to be on like using the machine learning service and like the third pillar within AI. Most people would say that ML is hard, but I would argue that it's not necessarily hard. From my own experience working with different like customers, I think the most challenging part isn't actually the model training, because I think most data scientists are comfortable working within their own Jupyter notebooks. They can use like popular libraries like TensorFlow, Keras, and build models fairly easily. But the challenge is really, how do we deploy it? How do we make use of this model? Where do we deploy it? How do we control like model versioning? So I feel like everything, like I guess like the difficult parts would be really the operationalizing of that ML model. I think that's the hard part. And really the ML code itself is not that complex. We're not building neural networks from scratch. We just leverage what's built by research teams and like open source, I guess developers are contributing to that source code. So just leveraging that and then really applying it. So it's more like applied for most data science use cases. It's really like applying existing models rather than like researching and building new types of algorithms. So when you're building a model, there's obviously like different steps involved. Some of these steps can be as complex as many as like 15 different steps in like one single model iteration. And some of these are things like data ingestion, data analysis, transformation, so on, data splitting. And then there's the training call row where you're building while validating, performing some sort of hyperparameter optimization, and then of course training at scale in a distributed setting when you want to scale up to like say like petabytes of data. And then of course there's the rollout, which is actually packaging the model and finding the appropriate deploy target, some sort of like metric monitoring system, and logging as well, like maybe through app insights or log metrics, for example. And most data scientists may say, okay, I'm a data scientist and I don't really care about that. That's not my goal. I shouldn't really care about it. But unfortunately, the way things are moving forward in machine learning and AI, I think you will have to care about it. I think that's probably more important than actually building the model itself. Being aware of like how different things are moving, different components are moving, where are we going to deploy some like our given model? Is it going to be real-time scoring? Is it going to be batch inferencing? But I think moving forward as the AI workloads move from like simple logistic regression or like some sort of like linear regression models to more complex ones, like complex deep learning, LSTMs, you will have to be aware of that as well. In most cases, most companies, I guess, will generally have like 1 or 2 data scientists. They're just starting up. This is the case from my own experience. Most either have 1 or no data scientists at all. And this is the common workflow. The data scientist like builds a model, and then they pass it on to, let me close these. So they pass it on to the ops team, and what happens is ultimately it fails apart because they have not like tested that model on other hardware. They've only tested it on their machine, and then they complain saying that, oh, it worked on my machine. What's going on? So maybe you missed like a library. Maybe you have like a runtime error. You're missing a core version. Maybe there's a version difference. Maybe you're using Python 3.6, but the hardware accepts only Python 3.7. So a lot of things can go wrong. And some of these, like I guess, pain points are data scientists are often working with software developers, and there needs to be some sort of like bridge that helps them communicate. And usually, like on traditional working on your local laptop, scripts are stored on the person's machine, and like processes are not reportable. There's no model versioning, no model versioning like naming. There's no real naming practice in place. Accuracy is determined during training, and we really don't know how the model is going to perform in real-time settings. There's no thresholds in place or like metrics or protocols to determine when to deploy or operationalize the model. And these are all common issues when you're starting up with machine learning in a mid-sized company, or even like big companies too will have the same problem as well when they're first starting their ML teams. The way we can, I guess, sort of alleviate some of these problems are to really learn what software developers are doing and apply those principles into machine learning as well. And we can start at like small steps. We can, I guess, like summarize that into like 3 different categories. And I think most companies usually go by this, I guess, philosophy of people, processes, and technology. And all of these 3 categories would be equally important in making a successful MLOps workflow. And we'll start by looking at like people involved. So in any like I guess like business setting, there's the data scientists. Some are at like different skill levels. Some are very mature. They're comfortable using like open source platforms. They can code, use like various libraries, R, whatever they need to get the model built. But then there's also like citizen data scientists who are more like business users, maybe managers who are just getting into ML. They want to use more like auto ML or drag and drop features. And of course, you have software developers who are really experienced at like with DevOps components, and they're good at like delivery, but they may not know, they're probably not too sure how to approach like the model and like data. When you add in data and model into your DevOps, it gets a bit tricky. So there's different personas involved. Yeah, and more about like what I explained earlier. The developer focused on using pre-built AI, and data scientist is comfortable using like most languages, and the citizen data scientist is essentially like could be like a statistician or like a domain knowledge expert, but they may not have the programming skills or like knowledge of different libraries to make that into a functional model. And then the most common problem with most hiring in like most companies is like the unicorn problem, where they expect data scientists to do all of the above. They want the data scientist to be like a data engineer. They want them to build like your data pipelines, data ingestion, work with IoT, build models, even like deploy, be the DevOps person, all of the above. That's what most people look for. Just from my own experience looking at like job postings, and that's a common problem, and it really puts a lot of stress on most data scientists, and it's really hard to find someone that can do all of it. Generally, most people specialize in one aspect. So the idea is to surround that data scientist with a team to be successful. So you're not going to be able to do MLOps with just one data scientist who is like this unicorn, brilliant person who can do it all. Maybe there are a few like that, but generally that's not the case in like the average human skill set. So you have different people like the developers, business analysts, statisticians, data engineers, and of course the data scientists. And all of these personas working together can make a successful DevOps or MLOps practice. And then there's also the processes involved. So these are like list of steps that you might have to take in order to make that happen. And just a quick intro into DevOps. It's really about bringing like people, process, and products together to automate software delivery and provide that continuous value to customers. And there's things like continuous integration, which enables developers to collaborate more efficiently with each other and like really blend their work into a code repository. So every time you commit new code, add in a feature branch, it goes through that like DevOps cycle where it goes through some sort of like testing, like I guess like local testing, maybe UAT testing, and then eventually it ends up in like production. So that cycle, there's the continuous delivery from like build, test, configure to production environment, and of course continuous learning and monitoring. Like you just perform, you look at how the model or like I guess the code in this case is performing. How many hits am I getting? Let's say you build a chatbot and you see how many times I'm getting like correct responses and incorrect responses and so on. Really, like MLOps is like a combination of the DevOps principles. Uh, the only difference here is we added one more circle where there's the ML itself. And ML involves things such as business understanding, data acquisition, data modeling, dealing with missing values through imputation techniques. There might be feature engineering and like feature importance that may go through it, selecting the correct algorithm and being aware of like what kind of data are we dealing with, real time, batch, or like weekly training, monthly training, and so on. And of course, everything else would be like the same process, very similar process, except you have like some data and like a model to deal with as well. Like you still have your testing, continuous integration, continuous deployment. You have your continuous feedback and data loops, and also like model monitoring. That would be like the additional things that are added to from a traditional DevOps approach. And of course, we have like the personas again, like the development and operations team on one end, and data scientists on the other end, where the data scientists will cover most of the ML and like create, plan, development of the model parts, and like the developers and operations team would be more vigilant of the release cycles, release principles, policies, and monitoring, and so on. And I won't really go into like team data science process, but it's essentially built based on like the CRISP DM, which stands for cross industry standard process for data mining. It's really like an industry standard that has like a set of like I guess documents, methodologies, and steps that it's recommended that you follow to really like drive insights through analytics projects. And this is a continuous loop here, which has business understanding, data acquisition, deployment, modeling, and there's bidirectional arrows because having a better understanding of the business can definitely impact the type of modeling you're going to do, and all of the other components as well. Like a better business understanding will lead to understanding the data better and like understanding which type of data to use. And knowing that will go back to like business understanding and domain knowledge. Maybe you might go back and ask those challenging questions about what other data sets can we use, what else can we bring in, is there like a IoT data that we can use, and so on. So really, it's just a list of steps. This whole data science process can be a presentation on its own. So just a quick intro into what that's about. There is a GitHub link with all the documents and artifacts that are involved in a team data science process. And generally it looks something like this. There's your different pillars, like the horizontal axis are your pillars, like the business understanding pillar, data ingestion, modeling, deployment, and acceptance. And there's the blue icons, which is really you're just following that arrow, like you create like a template repository, you create a project charter, and like the green ones are like the deliverables, like what do we need in that phase? Create like a project charter, like a POC documentation where you like talk about like all the different people involved and like the different data sets you may be consuming and so on. And of course, there's like the solution architecture diagrams, model report, how's the model performing? Maybe once you deployed it, maybe there's like a dashboard, a Power BI dashboard that monitors metrics and so on. So you can make use of this GitHub repository. I'll provide the link in the slide, and then use that as like a framework if you're starting up a data science practice within your company. And of course, it's just one way, right? It's just Microsoft's way of approaching data science problems. There might be 100 different ways. It's up to you, like which methodology works best. And finally, we're going to take a look at the technology itself. I know I'm like really, it's more like high level. It's not really taking a look at like Azure DevOps in detail or like Azure Machine Learning Service. That wasn't kind of like the idea of this presentation. I wanted it to be like more high level. And then in future presentations, we can go deeper into specific technology pieces. But in this case, the main goals for MLOps are really having like produce repeatable experiments. You want to have that model creation and behavior on like some sort of trigger, like published as a pipeline that can be triggered. You also have your evaluation of the model predictions. We're also managing model lifecycle, implementing like the model iterative training, continuous integration, and operationalizing that model. And ultimately, what you have, you start with some data, you generate some features, you create a model, you have services like deploy services like a web service or web app or whatever service that you want to use for deployment. And then you generate some predictions and you get more data from those real life predictions. And then you, again, it's a loop, right? You take that data and then retrain, and it's a continuous cycle where more data you get, relabel if necessary, and then recreate. Maybe the model performs worse or maybe it performs better. It really depends. It might also be good to be aware of like data monitoring or data drift monitoring as well, because with changes in like maybe environment or input data, that can definitely degrade your model prediction accuracies. So one of the tools, I guess, in this case would be the Azure Machine Learning Service. And this is our end-to-end platform for performing everything as code. You can essentially install this Python SDK and build from data ingestion to deployment in an AKS or Azure container instance can be done through this SDK. There's also a portal as well, like the ML portal, which I will show you guys briefly. And there's different components in it. This can be another presentation on its own, but at a high level, there's automated ML, there's managed compute, GPU clusters, CPU clusters, pipeline services to integrate with ADO, one-click, one-line deployment. It all does it for you. The whole idea is that the data scientist worries about like experimentation and not so much about the infrastructure or like how do I set up an AKS? What are the like metrics that go in? What are the parameters? Just set that aside and only focus on rapid model training and deployment. That's the goal of having an SDK. And in the backend, it's doing all the resource management, deploying the appropriate, like I guess, container registries and so on in the backend. Of course, it integrates well with most open source frameworks as well. And you can really think of it as like another library that you can use to, I guess, capture metrics, model runs, use like some sort of Git integration with your code, and build these like I guess pipelines that can be triggered with ADO as well. So let me just show you one more slide here, and I'll go on to that demo of Azure Machine Learning Service. So within Azure Machine Learning Service, they've used the notion of pipelines. One pipeline can be, I guess you can think of like data ingestion, data prep, model training and building and deployment as like 4 independent pipelines. And within these pipelines, you can have other steps such as data normalization, some sort of data transformation, validation, and feature engineering as like sub-steps. And you can think of these as like modular steps where each of these can be triggered independently once you deploy this pipeline as a HTTP endpoint. And really just trigger them, and triggering that endpoint through maybe like functions, through ADO, will run all of these different steps within the pipeline. And you can select which ones to. Maybe you don't want to ingest new data. Maybe you just want to do the retraining step. So you can just do that step, or you want to modify, say, like transform the data into like with different metrics and run this step alone. So you can control like which parts to run, and you can have different. I guess like if you have a team of data scientists, you can have different people working on different parts of this, like this modular architecture, and each person can specialize in like one particular step. So that kind of allows you to be more agile in that sense. And this all, like you might be wondering, like, what does this have to do with ML ops? This is like the foundations, right? You have to start somewhere, and this is a good starting point of breaking your work down into like independent sections, so that that can be dealt by with different specialists. Maybe like there's an AI engineer who focuses more on model deployment, and then there might be like a research engineer who focuses on like data preparation and validation and feature engineering, and like an ML algorithms engineer who builds that, fine-tunes that algorithm by selecting the appropriate algorithm. So different people can be assigned different tasks, and they can publish and submit their components once they're done. So let's just take a look at the demo of the actual Azure ML service. This is the Azure DevOps. I won't really go into it because there's way too many things to go into in like a 40-minute session. I wanted to keep it like fairly high level, but this is what the Azure Machine Learning service looks like. This is the studio, and it's not the SDK. The SDK itself is like a library that you can pip install, and or install through the, not the pip, sorry, install through the command line, Azure command line. And on the left, you have notebooks. Where I think most people are familiar with notebooks. They're just like Jupyter notebooks. I have one notebook running here. I call it Notebook VM with 8 cores and 28 gigs of RAM. You can select the appropriate notebook type by going to Compute. And you can see all your resources that are available here. If you want to create a new notebook, you can select the appropriate like VM size, and you can use this as your, like, I guess your orchestrator. Like you do your code, you run the Jupyter notebook, run some snippets, do your experimentation in this notebook, and you can access this notebook through Jupyter Labs, RStudio, or like Jupyter Hub. So just it's pretty straightforward. You just sign in through your Active Directory, and then it takes you straight to that VM, and it has all the pre-required libraries. Most of the common libraries like TensorFlow, Keras is already pre-installed. So you don't have to worry about, like, if you want to say like run a GPU task, you don't have to worry about configuring those NVIDIA CUDA drivers, which is like a nightmare on its own, setting that up on like a Windows machine. So this gives you like all the backend stuff is done for you, like all the engineering is done, and you just go ahead and start working with your code, run your code, start importing like these Azure ML core libraries, experimentation, workspace, dataset, and so on. And yeah, like go begin experimenting from there. And you can also, I guess, use this SDK to create your targets. Let's say I want to create a training cluster through code because you want to I did develop everything as like infrastructure as code. You can certainly do that through code. Or if you're just getting started, if you're new to ML and you don't want to do MLOps just yet, you can definitely create it through the interface as well. You can create compute clusters. I think this, you can have GPU clusters. You can select the appropriate like infrastructure for your workload. If you're doing some sort of like memory optimized operations, you can select one with more RAM and so on, like general purpose ones. Or you can just get started with like the most basic one, like data science, standard D1 instance, and like start developing your models there. And there's also like inference clusters, like for example, like AKS cluster or Azure Container Instance, where you can deploy that model as a web service and like use that to score against your model. And you can also attach like an external compute as well, like HD. It's like cluster, an external VM, or even a Databricks cluster as well. So that's kind of like just a really high level overview of the Azure Machine Learning service. There's also other components as well, like the designer, where you can use like drag and drop features. There's lots of different like algorithms for drag and drop that you can use. You can embed like Python code and so on, and create web services just by just dragging them across like that. Train a model, select some hyperparameters, and just connect them together through a data source, and you can build models without even writing a single line of code. And there's, of course, our pipelines. For example, I've ran a few pipelines in the past, and this one seems to have failed, so I'll go back to another one and see which pipelines there are. These are just a visual representation of your pipeline. So whenever you create a pipeline, like for example, like feature engineering or data engineering step, you can visualize all of these steps and see what's happening there. And each of these pipelines can be executed independently as well. Once you publish them as like a endpoint, REST endpoint, you can consume them as needed, connect the results to another service, and develop your pipeline visually as well. And of course, you can have all your models stored here in your model registry here. You can register new models, provide like the framework name, and just with just a few clicks, you can register them through the UI, or with the code as well. If you want to employ like DevOps principles, then you would do it through code. So that's kind of like quick intro to ML service. There's a lot more. I just don't have enough time to go through all of them, but I will go back to the presentation and just quickly go through a few more slides, and I'll show you guys a quick demo repository that you guys can actually start using for your first MLOps projects. So back to our slides. So what most people do is most data scientists use some sort of Jupyter notebook locally, but this approach is not ideal because you don't have the model reproducibility, validation, or like deployment or retraining capabilities. And sample example of what an app developer would be doing using DevOps is they would collaborate using some sort of Git repository. They would build, test, release, and monitor the app. So we want to mimic that workflow. We just learn from what's already being done rather than reinvent the wheel. So you just try to mimic what they're doing. So you have Azure Machine Learning Service, which can help you provision like the code repo, data set, and like versioning for all the metrics that you're tracking. You can train the model. You can use automated ML to automatically train models, or use the ML pipelines as steps as part of your training. And of course, there's also hyperparameter tuning and an array of different tools that you can use for the training process. And then you validate that model, which would be like the test app in our case. You have some threshold, your like metric thresholds. You validate it, and if it passes that particular threshold, then you can certainly qualify it for release pipelines. And then you would ultimately package that model and prepare it for deployment and like choose your target, ACI, AKS, or array of different deploy targets. And then you would have some sort of model monitoring where you would see how well the model is performing and retrain if necessary. Or at this step, maybe you don't have to retrain the whole thing. Maybe you're just tuning a few parameters and retraining, or go back to the beginning and then retrain with different metrics as well. And generally, the way it would work is any code change that you'd make to any of the Python script, it would trigger that retraining process and just exactly do what like a developer process would do. Like it would go through that process and help you create that automatic deployment process. So an MLOps workflow may look something like this. There's the data catalog, a component that's doing like a data pipeline. That itself might have like 20 steps, maybe in like Azure Data Factory, like that's querying from a data lake. That's one step on its own. And then there's the machine learning pipelines where you have like your data preparation, selecting your algorithm, and all the different steps that I showed earlier. And then, of course, there's the release pipelines where you package the model, certify the model for the release app, and then you have the continuous monitoring feedback. And of course, there's the data drift to see model degradation, performance degradation. For example, if there's like a change, if you're trying to predict, like say, orange or like ice cream sales, like weather and time would be an impact. You cannot use a model that's trained in summer for like a winter scenario because that would not work very well. And then, of course, you have your model registry where you can keep track of all your different models and use and have like guidelines where only a model meeting like a certain threshold will be pushed for release. And if the model is performing worse than the current trained model, then it would not. You would continue using the old model. And I know I have only like a few more minutes, so I wanted to show you guys. There are some examples. I'll share the slide deck with you guys. They're pretty straightforward. Like some of these are like some reference architectures using Databricks, Azure ML Service, DevOps, and like build pipelines. And then you can track the metrics in Power BI. There's really like 100 different ways of, I guess, building your MLOps architecture. But I wanted to show you one really good repository that my colleague had been working on. And I can definitely share the link to this as well. And I've forked his repository. Please do check it out and start leveraging, fork this repository and start playing around with some of these components. So this kind of gives you like a full CI/CD enabled MLOps pipeline. Let me just zoom into this diagram here. So this is what it kind of looks like. It doesn't have to be this complex. It can be much simpler with only like say 3 steps to begin with. You have like some sort of like data engineering step. You have like the data scientist who is modifying some sort of Python code, and then that triggers an event that would like trigger the build pipeline, the DevOps pipeline, and then it would go through the different steps within Azure Machine Learning, including data preparation, training, evaluation, and ultimately it would register that model if it passes a certain metric threshold, or if it performs better than the current model. Let's say we're doing some sort of classification and we're getting, say, like 81% accuracy, but then the current trained model is giving like 82% accuracy, then it would fail and it would not push that new model into the release pipelines. But if the model is performing, let's say it's performing, let's say a recall rate of like 83%, then it would push that model, save it into the Azure ML model registry, and then trigger another build pipeline where it would release that into QA as a web service, containerize that model and deploy it as the ACI. And then once it passes through the QA stage, either through like unit tests or like manual testing, however you want to like orchestrate that piece, then That approval will be given by like the QA quality assurance engineer or like another data scientist. And then we'd ultimately move that into prod and then deploy it into an AKS, Azure Kubernetes Service, where you have like multiple pods, like different containers, container orchestration service, so that you have in a production setting, you're not going to get overloaded by only having a single container instance, which is scoring on the model. So you might have as many as 12 different containers that are scoring, and the AKS will orchestrate that, and then that will also provide us, I guess, through Azure Application Insights. It gives you some sort of telemetry information and like triggers and like accuracy and various other like model scores can be observed within Azure Application Insights. And this particular repo is super easy to follow. Like it starts with like an ML pipeline step where it shows you how to build the actual ML pipelines, uh, and then like how to trigger your 3 steps, like data prep, model training, and model registration. And all the code is available here. I won't really go into the code, but really it's 3 steps. You define an ML pipeline, um, and then you have your sort of like push and trigger pipeline so you can programmatically code. And of course, we're not running this Jupyter notebook. This is just for learning purpose. What you're really running is, if I go back to the repo, we're actually running the scripts themselves. We're actually generating like Python scripts at each different stage. Like for example, deploy model is a step on its own, and there's the code. And this pipeline, this is called in Azure ML pipeline, and that pipeline gets triggered in Azure DevOps. Like for example, a build release pipeline here gets triggered once, say, like code change is being done. So my colleague had like ran a few models here. He's added some images to the notebook, and like now that there's new training data, it triggers that notebook and trains on those new images, and you can see like all the training jobs and like different steps that are performed at that step. Like for example, there's check out the actual repo, like use that current repo, use Python 3.7, install the dependencies, run some unit tests, publish the results, create like a scoring artifact, and so on. And just pretty much like a high level overview of how it looks like. Of course, like I just didn't have enough time to go through every little step in detail, but yeah, I think I've reached my end. So I'll stop there and